Self-Practice 1.1D KSSM Form 5. Question number 1. Lee fills a tank with water using a rubber hose at 8 a.m. At 11 a.m., Lee discovers that the tank is filled with 48% of water. A. Write an equation that relates the volume of water V that is filled into the tank with the time taken T. Okay, so to answer this question, first you must know when the duration of time increases, the volume of water in the tank also increases. So what is the variation? The variation is V varies directly as T. So we change the variation into equation. V equals, so you add the letter K, the constant, and write down T. Okay, now you need to find the value of K. To find the value of K, you need to substitute the value of V and the value of T. Okay, so what is the value of V? 48% of the water. So 48% is 48 over 100. If write in decimal is 0.48. So volume we just assume is 0.48 equals K. The time is from 8 a.m. to 11 a.m. So it's 3 hours. So T is 3. So K equals 0.48 divided by 3. K equals 0.16. After we find the value of K, then we write again the complete equation. So V equals 0.16 T. This is the complete equation. B. At what time the tank be fully filled with water? So fully filled with water is 100%. So if right in fraction is 100 over 100. Okay, so now we use the complete equation. V equals 0.16 T. Okay, now the volume is 1 equals 0.16 T. So you know opposite of multiply is divide. T equals 1 over 0.16. So the value of T is 6.25 hours. Okay, so if I write in hours and minutes is 6 hours. This one 0.25 hour, I change to minute, so I multiply 60. We can get 6 hours 15 minutes. Okay, now we need to find at what time the tank be fully filled with water. So start to fill in the water at 8 o'clock. So if I write in 24-hour system, 0800 plus 0615. Then I will obtain, here is 15 and here is 14. So 1415. So conclusion, at 2:15 p.m. the tank be fully filled with water. Question number 2. Amina wants to cut a few triangles from a piece of card. It is given that the area of the triangle cut and centimeter square varies directly as its base as centimeter and its height ycm. At the beginning, she cuts a triangle with a equals 14, s equals 7, and y equals 4. A. Write the relation between A with S and Y. So now we write the variation. A varies directly as S and Y. Okay, so we change the variation to equation. A equals K S Y. Okay, every time when we write this step, after this step, we need to find the constant. In order to find the constant, you need to substitute the value of A, S, and Y. So from here, we can get the value of A, S, and Y. So A equals 14 equals K times S is equal 7 times Y equals 4. 28K equals 14. So now we want to find the value of K. So we move the number 28 to the opposite side. Okay, opposite of multiply is divide. So K equals 14 divided by 28. K equals 0.5. So the complete equation is A equals 0.5 SY. Okay, now B. Amina plans to cut the second triangle with the value of base increased by 20% and the value of height decreased by 10%. What is the percentage of changes in area for the second triangle? Okay, so now here base increased by 20%. Okay, so how? So we still use A equals, the constant is 0.5 times the original base is 7 centimeter. Now increased by 20%. So 7 plus 7 times 20%. So 20 over 100. Okay, times again, value of the height decreased by 10%. The original height is 4 cm. So means 4 minus 4 times 10%. So 10 over 100. 15.12 centimeter square. And now we need to find the percentage of the changes in area for the second triangle. The area for the first triangle is 14. The area of second triangle is 15.12 minus the first area of first triangle 14 divided by 14 times 100%. Okay, this is how we find the percentage of changes in the area for the second triangle. Okay, so you will obtain 1.12 over 14 times 100% and equals 0.08 times 100% and you will obtain 8%. Question number 3. A pizza shop sells 3 sizes of pizza at different prices as shown in the diagram on the right. Does the price of pizza RMP vary directly as the surface area (a centimeter square of the pizza)? If it does not, which size of the pizza is worth buying? Okay, first I write all the information in the box. First, I write all the information in the table. Price P. So first pizza is 12 ringgit. Second pizza 25 ringgit. Third pizza 35 ringgit. And surface area of the pizza okay, the shape of the pizza is circle, so we use the formula A equals pi r square. So area of the first pizza is pi times 7.5 square equals 176.74. The surface area of second pizza, pi times the radius is 23 divided by 2 equals 11.5. So pi times 11.5 power of 2 equals 415.53. The third pizza, pi times 15 square. So equals 706.95. Okay, so now if we want to determine whether the price of pizza RMP vary directly as the surface area of A of the pizza, we need to find the constant. Okay, so how to find the constant? First, P varies directly as A. If P varies directly as A, so we write P equals K A, and the constant will equals P over A. K. So we want to find the constant. K is equals P over A. So just now P is 12 for first pizza and A is 176.74. So equals 0.0679. Okay. So for second pizza, we also count the P over A. P is 25 and A is 415.53. So equals 0.0616. Okay, so for the third one, 35 divided by 706.95. Okay, equals 0.0495. We found that all these three values different. Okay, so conclusion, the price of pizza does not vary directly as the surface area a centimeter square of pizza. Okay, so now we need to determine which size of pizza is worth buying. Okay, if we look at here, we look at the first pizza, the price is RM 0.0679 for 1 centimeter square. Means 1 centimeter, if the area 1 centimeter square, you need to pay 0.0679. For second pizza, 1 centimeter square, you need to pay 0.0616. And third pizza, 1 centimeter square, you need to pay 0.0495 ringgit. Okay, so which one cheaper? If you look at here, of course, is the third pizza cheaper. Okay, so the conclusion is the pizza with diameter at 30 centimeter is more worth it.